So some of the students we are meeting for the first time. So just a brief introduction. I am Sharvari Dev. So this is out of interest and out of my observation that you people or students studying in ninth standard, many a times they find this particular concept a little difficult to understand. So this session is going to cover just the brief introduction, and the mathematical part will be a little bit concentrating on. Okay, so we'll be starting with our session, and I hope that you have kept your pen and paper ready, so that in case you have to solve some of the questions, you'll be able to solve them quickly. Okay, so I'll start sharing the screen. In case of any doubts, you can send your doubts through chat. In the end of the session, we'll definitely take the questions if any. But in between, in case of any doubts, you can send through chat. Okay. So we start with the session, mole concept. So students who have joined from India, and we have a couple of students joining from the US. So in India, 9th standard students have this particular concept when we start studying about atoms and molecules as a part of chemistry. So in chemistry, you must have already observed that there are various chemical reactions that are taking place. So chemical reactions involve reactants and products. And those reactants and products, they need to be in certain proportion. You must already have learned about the law of conservation of mass. Do you recall it? Do you recall law of conservation of mass? And then the law of proportion of mass also. So these two laws are very much important whenever we are carrying out various chemical reactions. So uh, in that case, we need to know the exact proportion or exact amount that is involved in the reaction. But as you know, all the elements and compounds that we use as a part of reactants in these chemical reactions, their basic unit is atoms or molecules, which are very much tiny in size, and therefore their number involved is very huge. So to handle such a huge number, something called as mole concept has been introduced. So that's what we are going to see here. So before we start our session, so are we talking about this mole? Can you see the picture? So are you aware of this particular animal? There is an animal called as a mole. Okay. And actually it's a pest, because it carries lot of destruction in farm, and it is a headache, a big headache for the farmers. So is it a mole that we are going to discuss about? So of course the answer is no. So we are not definitely going to discuss about this pest, but we are going to discuss something which is very much important, for the chemists. Chemists are the people who are involved in the study of chemistry. So mole concept or the moles, they are the useful uh, uh, entity used by chemists widely. And the study of mole concept or study of measurement of material and substances, it itself is a separate topic in chemistry, and it is called as stoichiometry. So once you grow up, if you have keen interest in chemistry, you can definitely opt for studying further in this particular topic of stoichiometry. Okay. So what are we going to discuss about now? Which moles are we going to discuss about? So what is the mole for us now? Now we are going to study mole from the chemistry point of view. So the definition says that it's a unit. Mole is the unit of amount of substance. So what exactly does it mean? So in case we consider a simple chemical reaction of sodium and chlorine, it gives us NaCl. So in terms of moles, how does it look like? It looks like that take 1 mole of sodium 1 mole of chlorine combined together, we get a mole of NaCl. Okay, the pictures are a little fancy compared to the theory, but still, do you feel that it is giving you any idea? Is it giving you any clarity over the idea? So, still, it may not still be clear, right? So what are we going to do? How should we approach this idea? How should we approach this idea to understand it clearly? For that matter, we are going to consider some everyday examples. So what are the everyday examples? So everyday examples, you must have seen in your day-to-day life that there are certain units of amount of objects which we use very often. For example, a dozen. So a dozen is very much commonly used. A score, as a part of your mathematical problem solving, you must have definitely encountered this term, a score, a gross, a grand. And even though we do not use this term a ream, it is very commonly used in printing media or the printing industry, because a ream means 500 papers. Because you can see that a single sheet of paper is so thin, so to keep a track of a single sheet of paper, so we need bunches, right? Whenever we have to carry out the printing job, we need papers in the form of bunches. So how should we keep track of count of those papers? So for that, people have come up with a unit called as a ream. But as you all can see that we quite often use this unit dozen. We use this unit dozen, which means 12 units. So what does it exactly mean? So we are going to take an example. So in this particular example, we are going to consider tennis balls. Okay. So let's assume that we have some tennis balls, and it is given that if we have tennis balls, these 12 tennis balls, they weigh 600 grams. So this is the given condition for us. Okay. Now, let's assume that we get 2 dozen of tennis balls. So can you tell me how much will they weigh and what will be the number of balls which will constitute 2 dozens? Can someone tell me? Or maybe through chat you can send me the answer. Can you send me the answer through chat?
24 balls.
Yes, 24 balls and weight. Who else can answer?
1200 grams.
1200 grams. So you can see that when I was talking about 2 dozens of balls, that corresponds to a certain number, which is 24, which corresponds to the weight as well, which is 1200 grams. Okay. So a single unit, it gives us idea about the number of balls involved, also their weight together. Okay, now we'll take another example. For example, I told you that you have 1800 grams of balls. So when I say 1800 grams of balls and given condition is 600 grams correspond to 12 balls. So how much this 1800 will correspond to?
36 balls.
Yes, just a second. So it will correspond to 36 balls, and 36 balls correspond to 3 dozen. Okay. So you can see that here, these three quantities, the unit dozen, amount or quantity of balls, and their weight, they are interlinked. Okay, we'll take one more example. For example, the weight of balls is 2100 gram. Then how much will be, how much will it correspond to? I mean, in terms of dozens, how many dozens shall we have? It will be 3.5. Okay, so this will 2100 of weight will correspond to 3.5 dozens of balls, and in terms of number of balls we'll have 42 balls. And one more example. Now I have given you number of balls. You are supposed to tell me how many dozen they will make and how much will be their weight, with the starting knowledge of 12 tennis balls corresponding to 600 grams. So for 60 numbers of balls, how many dozens will they make? 5. They will make 5 dozens of balls and weight will be 3000 grams. Okay, so I hope that this idea is a little bit clear to you, that dozen, number of balls and weight of balls, these three quantities are interlinked with each other. Now, why are we discussing about balls, their weight and dozen? How is it related to us? Of course, it is related to us because we are going to extend this understanding to mole concept. And why did we take example of dozen or a ball? Because we can visualize them. Because we have bought items in dozens. For example, we buy a dozen of banana. Then during summers in India, we buy 4 dozens of mangoes or 5 dozens of mangoes, right? So the quantity or the unit dozen and how many in numbers that we can visualize, we can actually see. Hence, we have taken this scenario. With this understanding, we are going to proceed further to understand about mole. Okay, now coming back to the moles. So we discussed a lot about the dozens, their numbers, or how many balls shall we have and how much weight will be there, right? So we are coming back to the mole. Now, when we are starting our study with respect to mole concept, we have a prerequisite. We need certain background knowledge. And what is that? In chemistry, or the substances around us, they are in the form of either element or compound. Aren't they? The substances around us are in the form of elements or compounds. So when we have a substance which is formed of an element, for example, pure gold, we Indians love gold, right? So if the substance is made up of pure gold, what shall be its basic unit? What shall be its basic building block? Can someone tell me? Ninad can tell me, I think. Ninad, can you tell me? Ninad, are you listening? Ninad? Maybe I think I shall give this answer. Okay, so when we are talking about substances where they are made up of elements, the basic block is an atom. Do you recall it, all of you? Do you recall it? At least you can raise your hand, no? So that I get to see whether you are following my discussion or not. Raise your hand, at least I can get to know that you are listening to my session. You're paying attention to my session. So whenever we have an element, its basic building block is an atom. And if we have a compound, then the basic building block is a molecule. So this understanding is very much required. Okay, this understanding is very much required. Now coming back to the mole. So as we discussed that a dozen corresponds to 12, similarly a mole corresponds to 6.022 into 10 raised to 23 particles. Wow, such a huge number, isn't it? A mole corresponds to 6.022 into 10 raised to 23 particles. It is far beyond billion. Do you know what is it called as? Or how do we read this number? For example, the way we say 1 million, 10 billion, 100 billion. So how do you know how this number is read? this number is read as 602 sextillion. So
Oh,
so to read such kind of big numbers, they have particular terms. So 602 sextillion, 200 something quadruplion, something like that. Okay, so this is a very, very huge number. Now we just have to imagine here, because we cannot see atoms, even we cannot see molecules. So we just have to imagine that we have taken a mole of a substance. How much do we get? The way we say that I have got 1 dozen of banana, that means I have got 12 bananas at home. Similarly, when I say I'm going to use 1 mole of sodium, that will mean in my reaction 6.022 into 10 raised to 23 number of atoms are going to get participated. Okay, so that's what it has been written here. This implies that a mole of a substance consists of 6.022 into 10 raised to 23 particles of that substance. And when I say particles, what exactly does it mean? Why have I used word particle? Because if the given substance is an element, that basic unit or particle will be an atom. If that substance used is a compound, then the basic unit or particle will be a molecule. And in some of the cases, they will be ions as well. So I hope you remember what are ions, right? Ions are the charged particles who have either lost their electron or gained electron. So when we say particles, they can be either atoms, molecules, or ions. Okay, so when I say 1 mole, that means 6.022 into 10 raised to 23 particles. Or in case I say 6.022 into 10 raised to 23 particles, that will imply I have 1 mole. Okay, so you must have to keep this number in mind. It's a very sacred number for us. Okay, so 6.022 into 10 raised to 23, a very sacred number. So what is this number 6.022 into 10 raised to 23? So this number is called as Avogadro's number. Who's this Avogadro? So he was an Italian scientist. It has been named in his honor. So, and after his death, okay, so even he was not aware that this number has been named after him. So he is not aware. He had already passed away, and after him, a French scientist named this particular number as Avogadro's number. So just an interesting trivia about Avogadro. So if you read further about Avogadro, his contribution is quite a lot in chemistry. Okay, but along with that, do you know that what was his basic qualification? He was a lawyer. Interestingly, he was a lawyer. So he belonged to a noble family from Italy. So he studied law. He started practicing law, but then he realized that his main interest is mathematics and science. And then he started this study, and he had a great contribution. And because of his contribution, this number 6.022 into 10 raised to 23 has been named after him. Okay, so sacred number, Avogadro's number. Okay, 6.022 into 10 raised to 23. So we have to remember this number, because henceforth, throughout this session and whenever you are studying mole concept, we have to use this number. Now again, to revise or to just reinforce what we have discussed, what is meant by particles and what is meant by having those or 6.022 into 10 raised to 23 number of particles, what does it exactly mean? We are going to discuss. So this particular table on this slide, it demonstrates us the same thing. For example, if the substance, given substance is sodium, so what is sodium? Sodium is an element. What is the basic unit of an element? It's atom. What is the basic unit of this element? It is atom. Okay. And so if I say that I have 1 mole of sodium, What does that indicate? What does it imply? It implies that we have 6.022 into 10 raised to 23 atoms of sodium. Please be careful, please pay close attention to this because you need to understand this. If we have an element, then 1 mole of that element implies that we have 6.022 into 10 raised to 23 number of atoms. Similarly, if I take hydrogen element, now again pay close attention, I'm talking about hydrogen element. So whenever we say hydrogen element, so its basic unit is going to be an atom. So 1 mole of hydrogen element will imply will have 6.022 into 10 raised to 23 number of atoms of hydrogen element. But now if you look at this next row, so what is it? It speaks about hydrogen gas. If you're aware of it, hydrogen gas exists in the diatomic state. We always, whenever we are writing about hydrogen gas, we always write H2. What does this mean? It means that hydrogen gas exists in the diatomic molecule state. So whenever we say hydrogen gas, it is denoted by H2 and its basic unit is a molecule. So when we say I have 1 molecule of hydrogen gas, when I say I have 1 mole of hydrogen gas, it implies I have 6.022 into 10 raised to 23 molecules of hydrogen gas. Okay, now here you can clearly see in the previous row we discussed about hydrogen element, and right now we are discussing about hydrogen gas. So we must understand when we say element, the basic unit is atom. So 1 mole will be made up of atoms. And if we are talking about hydrogen gas, it's a compound. It's in the diatomic state. Okay, so its basic unit is molecule. Therefore, 1 mole of hydrogen gas will have 6.022 into 10 raised to 23 molecules. Now, if we take another example, carbon dioxide. We discuss so much about carbon dioxide, isn't it? Since childhood, we have been discussing about carbon dioxide. How the percentage of carbon dioxide is increasing atmosphere. How is it causing global warming, isn't it? So carbon dioxide is also a compound made up of carbon and oxygen. So as I said that it's a compound, it means that its basic unit is going to be a molecule. Okay. So its basic unit is molecule. So when I say I have 1 mole of carbon dioxide, it means I'll have 6.022 into 10 raised to 23 molecules of carbon dioxide. Okay, I hope that you have at least somewhat the idea is clear. So 1 mole of an element implies we have 6.022 into 10 raised to 23 number of atoms. 1 mole of a compound implies we have 6.022 into 10 raised to 23 number of molecules. Now we come to the next part. Okay, so this was the basic idea about the mole concept. So what do we have to understand till now? What did we understand up till now? What is meant by a mole, and how is that Avogadro's number important for us, right? Now comes the next part. So it is completely a mathematical part, you can see. So, and actually it's a very simple mathematics. If you try to understand, it's a very simple mathematics. So we have learned about unitary method in our earlier classes itself, right? So we have to use the same logic here. So we have to use the same logic here, and you can see that the task is, so henceforth, or I hope that you have noted down some of the previous things which were a little important, but henceforth these are the numericals which are very much important. Okay, you must note them down in your notebook. So the aim is to find the number of particles when the number of moles is given. Okay, when the number of moles is given, we are supposed to find the number of particles. So what is the first problem? Number of atoms, we have to find number of atoms in 2 moles of hydrogen. Okay, so simply the way we write for unitary method, exactly in the same way we have to write here. So how many moles do I have? So 1 mole corresponds to 6.022 into 10 raised to 23. So 2 moles of hydrogen will correspond to how many atoms? So isn't it like the unitary method that we studied in the earlier classes? So 1 mole of hydrogen corresponds to 6.022 into 10 raised to 23. 2 moles correspond to how much? So we do the cross multiplication, 2 multiplied by this 6.022 into 10 raised to 23 upon 1. Okay, and once we do the multiplication, once we carry out the multiplication, 2 into 6.022, the answer obtained is 12.044 into 10 raised to 23. So in case a chemical reaction involves 2 moles of hydrogen, that time how many atoms of hydrogen will be involved in that reaction? The number will be 12.044 multiplied by 10 raised to 23. It's a very huge number, but can we actually see that number? It will be a very tiny sample of hydrogen, and of course you all must be aware of that hydrogen otherwise in the gaseous state. Okay, so have you all noted this down? Have you all noted this down?
Yeah.
Yes, ma'am. No, ma'am. Only 2 minutes.
Okay, so am I audible to all of you? Am I audible?
Yes, ma'am.
Okay, great.
Yes, teacher.
Who's this? Oh, Anushri.
Yes, teacher.
Great to have you in this call.
Thank you so much.
So once you have completed, please let me know so that we can proceed further. Okay. So shall we? Shall we? Shall we proceed further?
Yes, ma'am.
Who all are there? Rest. Can we proceed further?
Yes, ma'am.
Okay, great. So this was simple unitary method solution. Okay, and we have to follow this method only. But in your notebook, textbooks, if you see that you have been given the formula. But if this understanding is clear, then using that formula and solving the problem becomes very much easier. Otherwise, what happens is that the approach you take is you memorize the formula. If I have to find number of particles, if the moles are given, I have to use so and so formula. Okay, so memorizing and recalling sometimes make things a little difficult. But once you understand that this is simply a method of unitary method, or you have to solve this particular problem by means of unitary method, then it becomes easier. Okay, now we come to the next kind of a problem or next problem. Same thing, that we have been given mole and we have to find the number of molecules. So you can see here is that we have been asked to find number of molecules in 0.5 mole of hydrogen gas. So you can see that we are referring to hydrogen gas, which is H2. So the particles that we are going to refer are molecules. So we are going to find number of molecules. Similarly, the way we did in the earlier problem, the same approach we are going to have here. 1 mole corresponds to 6.022 into 10 raised to 23. So 0.5 mole corresponds to how much? Simply cross multiply and divide this quantity. Then we get the answer as 0.5 multiplied by 6.022 into 10 raised to 23 upon 1. So once you carry out this multiplication of 6.022 into 0.5, the answer that we get is 3.011 into 10 raised to 23. So number of molecules in 0.5 moles of hydrogen gas is 3.011 into 10 raised to 23. Is it clear? I need some interaction from your side now. At least something coming.
Yes, it's clear. Thank you.
Okay, great. So have you copied this down? Shall we proceed further?
Yes, ma'am.
Others, shall we proceed further?
Yes, ma'am.
Okay. Okay. Now you can see that up till now, we were being provided with the number of moles and we were supposed to find the number of particles, either atoms or molecules. Now, if we have been provided with number of particles and we are asked to find moles, what should we do? Same logic. Same logic. So you can see the problem here. Number of moles, we are supposed to find the number of moles corresponding to 9.033 into 10 raised to 23 molecules of carbon dioxide. 9.033 into 10 raised to 23 molecules of carbon dioxide. So here what should be your thought? 6.022 into 10 raised to 23 corresponds to 1 mole. So 9.033 into 10 raised to 23 corresponds to how much? So again the same thing, cross multiply. So 9.033 multiplied by 10 raised to 23 multiplied by 1 upon 6.022 into 10 raised to 23. So by practice, you'll realize that these numbers, so please understand this, whenever you have been given such kinds of problems, so usually the numbers they are given, they are always multiples of 6.022. Okay, so in this case, 9.033 upon 6.022, this gives us the answer as 3 by 2 or 1.5. So this 10 raised to 23 and 10 raised to 23, it gets cancelled. Okay, so we get 3 by 2 giving us 1.5. So the number of moles corresponding to 9.033 into 10 raised to 23 molecules of carbon dioxide gives us 1.5 moles of carbon dioxide. Is it clear? Again, it's the unitary method.
Yes.
Yes. So please copy it down and let me know once you are done. Okay. So shall we proceed further?
Yeah.
Yes, ma'am.
Okay. Okay. Now again, we'll see another kind of a problem or same problem, I mean similar kind of a problem, but a different scenario. So we are supposed to find number of moles corresponding to 12.044 into 10 raised to 23 molecules of He atoms. He is helium. Okay. So same logic. We have been given number of particles. So we must remember that relationship. 1 mole corresponds to 6.022 into 10 raised to 23 particles, or vice versa, like 6.022 into 10 raised to 23 number of particles make 1 mole. Okay, so here from particles to moles, hence the first column becomes 6.022 into 10 raised to 23 atoms of helium. They correspond to 1 mole. So 12.044 into 10 raised to 23 atoms of helium correspond to how many moles? Again, once we solve this by means of unitary method, we see that this 10 raised to 23 gets cancelled. And if you see, as I said earlier, that whenever such kinds of numbers are given, they are multiples of 6.022. Okay. So some of the numbers, it's like by practice, once you start practicing these problems, you'll realize that they are multiples of either 6.022 or 3.011. Okay. So once we solve it, we get to know that number of moles corresponding to 12.044 into 10 raised to 23 atoms of helium make 2 moles. Okay. They make 2 moles. Just a question, is there a black window coming in between here? I think, is there a black?
Yes, ma'am.
Yes.
Okay, so I'll do one thing, I'll stop sharing and reshare it with you, okay? Just a minute. Yes. So we were here. So what did we discuss till now? We discussed relationship between number of particles and moles. So in the beginning, we were provided with number of moles, and using our information, we derived or we calculated the number of particles that make that respective mole. In the second part, we were provided with the number of particles from which we calculated the number of moles. Now, as you can see in the previous discussion of our dozen and all, so you might remember that in that we had 3 quantities: dozen, then the number of balls, and third one was weight. So you can see that till this point we haven't at all discussed about the weight. Now atoms are so tiny, molecules are so tiny, even though they are tiny, they have mass and they have weight. Okay, now you can see that in terms of chemistry, so chemists use word weight here. Okay, chemists use word weight. So now we are going to discuss about relationship between the mole and the weight of a substance. Now you might remember that in our example, 600 grams of balls, 600 grams of balls, they correspond to 1 dozen. We also saw that if we have 1200 grams of balls, that makes 2 dozens. Now similar logic we have to extend to moles. So what is that logic? What is that weight? So it's a typo from my side. Actually it is 1 mole, it corresponds to gram atomic weight or gram molecular weight. Okay, so chemists always use word weight. So you can see here we discussed that a dozen of tennis balls means 12 tennis balls and their weight is 600 grams. So when we have 1 mole of a substance, definitely it will have some weight. What is that relationship? How should we calculate the weight if the number of moles is given, or how should we calculate number of moles if the weight is given? That's what we are going to discuss here. So you can see that 1 mole of particular substance has specific weight, and this weight can be either called as gram atomic weight or gram molecular weight. So again, in which case shall we use gram atomic weight? Whenever the substance involved is an element. Whenever the substance involved is an element, its basic unit is going to be an atom. Therefore, in that case, we will be referring to its weight as gram atomic weight. And if the substance involved is a compound, then its basic unit will be a molecule and its weight will be referred to as gram molecular weight. Okay, now we come to the next part. So just brief definitions, what is meant by gram atomic weight and gram molecular weight. So it is actually the mass of 1 mole of an element. Gram atomic weight is the mass of 1 mole of an element. So how do we calculate how much is it? So you must be knowing, or you already have been introduced to atomic masses of various elements. For example, if we take an example of sodium. Sodium is an element. Its atomic mass is 23U. Okay, its atomic mass is 23U. So when we have to figure out its gram atomic weight, how do we write it? Gram atomic weight of sodium is 23 gram. So whatever is its atomic mass, we simply write the number as it is, and the unit given is gram. Whenever we are talking about atomic mass, the unit is U, unified mass. The unit is U. And when we are talking about gram atomic mass, the unit is gram. But the number is same as that of the atomic mass. Now, if we take an example of atomic mass of oxygen, how much is its mass? It is 16U. So gram atomic weight of oxygen will be 16 gram. Okay. Now we need to know about molecular weight as well, because we don't only deal with the elements. Our chemical reactions, they involve compounds as well. So we must know what is meant by gram molecular weight and how should we calculate gram molecular weight. So what is meant by gram molecular weight? The mass of 1 mole of a compound, the mass of 1 mole of a compound is called as gram molecular weight. Now, do you know how do we calculate molecular mass? Do you remember how do we calculate molecular mass of carbon dioxide? Just a minute. So we'll just quickly solve once and then we'll come back to this slideshow. Just give me a minute, okay? Just a second. Okay. So my notepad is my whiteboard here. So we want to find molecular mass of carbon dioxide. Okay. So for this, we need to know atomic mass of carbon and atomic mass of oxygen. Okay, so how much is atomic mass of carbon? It is 12U. Okay, how much is atomic mass of oxygen? It is 16U. Okay, now in carbon dioxide, how many atoms of carbon are there? Only 1. And how many atoms of oxygen are there? 2. So how do we calculate? Molecular mass of carbon dioxide is equal to mass of atomic mass of carbon multiplied by multiplied by number of carbon atoms plus atomic mass of oxygen multiplied by number of oxygen atoms. So how many carbon atoms are there in carbon dioxide? How many carbon atoms are there in carbon dioxide? Anyone?
1.
Yes. So 12 multiplied by 1, because 12 is the atomic mass of carbon multiplied by number of carbon atoms, that is 1, plus how much is the atomic mass of oxygen? It is 16, multiplied by how many oxygen atoms are there? How many oxygen atoms are there? Anyone? In carbon dioxide? Anyone?
2.
Yes, it is 2. So it is a simple math. Use board mass. 12 into 1 is 12, plus 16 into 2 is 32. So finally the addition is 44. So molecular mass of carbon dioxide is 44U. Okay, so molecular mass of carbon dioxide is 44U. Okay, now coming back to our presentation. So you can see that I have written down here as molecular mass of carbon dioxide is 44U. So gram molecular weight of carbon dioxide becomes 44G. So whatever is atomic mass or molecular mass, write the number as it is, only the unit changes. So if it is gram molecular weight, the unit becomes gram. Okay. So I hope this idea is clear, because we are going to use this understanding further. Now you can see here, this table is very much similar to the table that we had in case of that dozen balls and their weight. Okay, it is exactly same. So we are going to start with carbon. One more thing I missed here. So I didn't miss. So you can see here is that gram atomic weight is the mass of that particular substance of a mole. So when I say that we have the substance is carbon, we have 1 mole. So what will be its gram weight? Who can tell me? Carbon is an element. So what is its atomic mass? Atomic mass of carbon is 12U. So how much will be its gram weight? How much will be its gram weight? Anyone? Anyone?
12 grams.
Sorry, I couldn't hear you.
12 grams.
Yes, 12 grams. So if we have the substance taken as carbon, its 1 mole has been given, its gram weight will be 12 gram. Okay, so how many will be number of particles? Concentrate at the number of moles. We have only 1 mole given. So how many particles will be there? Anyone?
0.22 into 10 raised to 23.
Yes, it is 6.022 into 10 raised to 23 atoms. As carbon is an element, the particles are nothing but atoms. So this is a table involving all 3 quantities: moles, number of particles, and gram weight. Okay, so we have been given with 1 mole whose gram weight will be 12 gram, and the number of particles will be 6.022 into 10 raised to 23 atoms. Now we are talking about helium. Oh, such a huge number, isn't it? We have 13 moles of helium. So do you know, does anyone know what is the atomic mass of helium? Helium is an element. So we must know its atomic mass. Does anyone know how much is its atomic mass? Does anyone know? At least atomic number. Does anyone recall its atomic number? No? No one? Helium, yes?
Is it 2?
Yes, atomic number of helium is 2. Okay, and its atomic mass is 4. Okay, so atomic number is 2, atomic mass is 4. So what does this mean? This means that 1 mole of helium corresponds to 4 gram of weight. 1 mole of helium corresponds to 4 grams of weight. So if we have 13 moles, what will be the gram weight? If we have 13 moles, what will be the gram weight?
It will be 13 into 4.
Yes, it will be 13 into 4, which is 52 gram, 52 gram, which is 52 gram. Okay. Now, at least this you could understand, right? So number of moles multiplied by the gram weight, so, per mole. So we got its gram weight. Now, how many particles will be there? How many particles will be there?
6.022 into 10 raised to 23 into 13.
Very good. So it is 13 into 6.022 into 10 raised to 23 atoms. As helium is an atom, its basic unit is an atom. Sorry, as helium is an element, its basic unit is an atom. Therefore, 13 moles of helium will correspond to 13 into 6.022 into 10 raised to 23 number of atoms. Now we come to the next substance, water. So we all know that chemical formula of water is H2O. Okay, and we have been provided with its 2 moles. Now we need to figure out what is the gram weight of 2 moles of water and what are the number of particles in 2 moles of water. I think we'll do some switching here. Again, we'll go back to my whiteboard. So we need to find the molecular mass of water. Okay, so water has 2 atoms of hydrogen and 1 atom of oxygen. 2 atoms of hydrogen and 1 atom of oxygen. What is atomic mass of hydrogen? What is atomic mass of hydrogen? Anyone?
1.
Yes, it's 1. Okay, so atomic mass of hydrogen multiplied by number of hydrogen atoms. So how many hydrogen atoms are there? 2. So atomic mass of hydrogen multiplied by 2 because 2 number of atoms are present in H2O plus atomic mass of oxygen So atomic mass of oxygen multiplied by how many atoms of oxygen are present in water? 1. So we'll substitute the values here. Atomic mass of hydrogen is 1 multiplied by number of atoms in the water are 2 plus atomic mass of oxygen is 16 multiplied by 1 giving us
32.
32 kashe? Is it 32? 16 into 1.
Sorry, no, 18.
Yes, it is 18. So it is 18U. So molecular mass of water is 18U. So what will be its gram molecular weight? Gram molecular weight will be 18 gram. That is 1 mole of water. 1 mole of water will correspond to 18 gram. 1 mole of water will correspond to 18 gram. Okay. So 1 mole of water will correspond to 18 gram. Now we come back to our table, the presentation. Okay. So we come back to the presentation. So here you can see that we have been provided with 2 moles of water. So we discussed that 1 mole of water weighs 18 gram. So how much 2 moles of water will weigh? How much 2 moles of water will weigh?
32. 36, sorry.
Yes. Yes, that's right. So it's 36. Okay. So you can see that Oh, so here I calculated the number first. So the gram molecular weight corresponding to 2 moles of water will be 36 gram. And the number of molecules in 2 moles of water will be 2 multiplied by 6.022 into 10 raised to 23 molecules. As water is a compound, its basic unit is molecule. Okay, are you noting this down, all of you? And are you following this?
Yes.
Are
Yes.
you following this? So, shall we proceed further?
Yes, ma'am.
Okay. Now we come to nitrogen dioxide. Okay, nitrogen dioxide is NO2. So NO2 means it's a compound. What is it made up of? Nitrogen and oxygen. So what are we provided with? We have been provided with 1 mole of nitrogen dioxide. Now we need to find molecular mass. Molecular mass means atomic mass of nitrogen multiplied by, we'll go back to my whiteboard again. Okay, so molecular mass, just a minute. Can you all see this screen?
Yes, ma'am.
Okay.
Yes.
Molecular mass of NO2 is equal to atomic mass of nitrogen multiplied by number of atoms of nitrogen plus atomic mass of oxygen multiplied by number of atoms of oxygen. Okay, so how many, what is the atomic mass of nitrogen? Does anyone recall? Does anyone recall? At least somebody should recall.
14.
Yes, it is 14. Multiplied by how many atoms are there? 1. Plus,
1.
yes, plus atomic mass of oxygen. How much is it?
16.
16.
Yes, great. 16. Multiplied by how many atoms of oxygen are present in NO2? How many?
2.
2.
Yes, great. So the calculation becomes 14 into 1 gives us 14 plus 16 into 2 gives us 32, giving us, how much is it?
46.
46. So the molecular mass of NO2 is 46 U. So 1 mole of NO2 will correspond to how many grams? 1 mole of NO2 will correspond to how many grams?
46 grams.
Yes, 46 grams. Now we go back to our presentation. Oh, but you can see as we only have 1 mole, how many molecules will be there? 6.022 into 10 raised to 23. This number we have to keep in mind, keep in our mind. Okay. So as we have only 1 mole, we'll have 6.022 into 10 raised to 23 molecules. And what will be its gram weight? It will be 46 grams. So at least up to some extent, you are able to join, or are you able to correlate these 3 quantities? So always remember, in chemistry, when we have been provided with a substance, with related to that substance, we have 3 quantities: number of particles, number of moles, and gram weight. And they are this way interrelated. Okay. Now, have you copied this down, this table? Have you copied this down?
Yes, ma'am.
Okay, great.
No, ma'am.
No? Okay.
Mhm.
Once you have completed, let me know.
Yes, ma'am.
Okay. So have you completed it?
Yes, ma'am.
Okay, so shall we proceed further?
Yes,
Yes.
ma'am.
Okay, great. Now you can see that we have to find the number of particles when weight of the substance is given. Now you can see that in the earlier parts, what did we do? The number of moles was given, we were finding the number of particles and vice versa. So it was simply a one-step problem, right? Simply, it was a one-step problem. Just make that table of unitary method kind of a thing and do the calculation, carry out the calculation and get the answer. But in such cases, if you can see that finding number of particles when weight of the substance is given, it's a two-step solution. It's a two-step solution. Whenever the weight of a substance is given, the first step is to find the number of moles corresponding to that weight, and from the number of moles obtained, we are supposed to find the number of particles. Okay, so in such cases, whenever we have to find the number of particles when the weight of the substance is given, it's a two-step problem. So first step, find the number of moles, and in the second step, from the number of moles obtained, find the number of particles. Okay, so as you can see that the problem statement here is that we have to find the number of molecules in 22 gram of carbon dioxide. Find the number of molecules in 22 gram of carbon dioxide. So we have been given the gram weight and we have been asked number of particles or molecules. So first step is from the given weight, find the number of moles. So you can see that as we know that 44 gram of carbon dioxide corresponds to 1 mole. So 22 gram of carbon dioxide corresponds to how many moles? Once we carry out the calculation, you'll see that we get, just a minute, we see that we get corresponding to 22 gram of carbon dioxide, we get 0.5 number of moles. We get 0.5 number of moles. So 22 gram of carbon dioxide corresponds to 0.5 number of moles. And we already know that 1 mole of carbon dioxide corresponds to 6.022 into 10 raised to 23 molecules of carbon dioxide. So 0.5 mole of carbon dioxide will correspond to how much? Simply have to carry out the calculation. It's a, just a minute, just a second. Just a second. Somebody's trying to enter the meeting and I'm not able to. Just a second, huh? So you can see that 1 mole of carbon dioxide corresponds to 6.022 into 10 raised to 23 molecules of carbon dioxide. So 0.5 mole corresponds to how much? So the way we did the earlier calculation, we are supposed to carry out the similar calculations, and you'll see that the number of molecules corresponding to 0.5 mole, that is 22 gram of carbon dioxide, is 3.011 into 10 raised to 23. So this is how we obtain the answer when we are asked to find number of particles corresponding to given weight. It's a two-step approach. It's a two-step approach. Okay. Do you want to note this down? Do you want to note this down? Are you able to hear me?
Yes, ma'am.
Okay. So have you copied this down, or do you need that earlier calculation as well?
No, ma'am.
So once you have completed this, please let me know so that we can proceed further. Done? Have you completed it?
Ma'am, completed.
Okay, great. So we move to now we have come to the end of the chapter. Now you can see that end of the session, not the chapter. So we have come to the end of this topic or discussion. You can see that it's a little bit of practice, which you are supposed to do it yourself at home. Okay. So just copy down what are you supposed to do. So you're supposed to find the number of atoms present in 46 grams of sodium. What is your problem statement? Find the number of atoms present in 46 grams of sodium. Again, you can see that weight has been given, number of particles have to be carried out. So it has to be a two-step approach. First step is to find the number of moles corresponding to the given weight, and from the number of moles obtained, find the number of particles. Okay, so do it as a homework. We already have created the WhatsApp group. You can share your answer through WhatsApp group. Okay, in case of any difficulty, let me know through WhatsApp. And I'm planning to give you some more practice problems through our WhatsApp group where we can discuss further. Okay, and with this, we have come to end of this session. Okay, so with this, we have come to end of this session, and at least I liked discussing this topic with you. I hope even you liked it. At least you followed the discussion here. You were able to understand the concept here. So we are ending our class here, but before that, anyone has any questions with respect to the topic that we have discussed?
No, ma'am.
Anyone else? Any doubts? So looks like either you understood the topic very well, or there are so many doubts that you don't have any questions. So anyway, as I said that we can always have the discussion through WhatsApp. We have this WhatsApp group created, and I'll definitely share a worksheet with you where you will be provided with some extra questions for practice, and we can discuss the solutions there. Okay, so it was a nice time having a discussion with you. I hope even you enjoyed the session. So maybe in future, we'll definitely try to have another session, have another meeting. Okay, bye-bye. Have a nice day.